Dialogue at the Wilson Center is a production of the Woodrow Wilson International Center for Scholars. And now here's your host, John Molesky.
Hello and welcome to the Wilson Center in Washington, D.C. Each week, Dialogue explores the world of ideas and issues in international affairs, history, and culture. And this week, science. Our guest is the director of the Wilson Center's Science and Technology Innovation Program, David Rejeski. Additionally, Dave is a visiting scholar at the Environmental Law Institute and previously served at the White House Council on Environmental Quality and the Office of Science and Technology. He joins us today to discuss the potential of 3D printing and digital fabrication. Dave, welcome to Dialogue.
Thank you. Nice being here.
I'm going to make a guess. I just learned this yesterday, seeing you do a presentation in-house, that 3D printing has been around since 1984, and my guess would be that people would be shocked and they would think of it as something that's relatively brand new.
Yeah, I think the thing that people need to know is digital fabrication has been around for quite a while. And so as soon as we started to have computers, we started to hook them to machines, and that happened right in the 1950s. So people started to develop what they call computer numeric control machines. So what we did was took those computers and we hooked them to milling machines, lathes, routers, drill presses. That was a huge revolution in manufacturing. The difference now was those are machines that actually produce things by subtraction. So we took a hunk of metal, wood, whatever it was, and we took things away from it. I think the big
so like
change,
a sculptor carving something
taken
out of
away.
Something.
We're milling it, we're drilling
yeah.
it. And I think the big change right now, and the thing that's important to keep in mind that's behind 3D printing is additive manufacturing. So we're starting with virtually nothing. We have a digital model of something we want to build, and it starts to build it from nothingness. And we'll see some pictures of that happening later in the show. But I think that's a huge shift. And I think the other thing that's happening is we're giving this to lots of people, the same way we took computers out of laboratories in industrial settings and put them on our desktop.
When you say a huge shift, other than the obvious, where it's just like a negative, a complete reversal of the image, why is it a huge shift, though? Does it suggest things like less waste? What makes it so different, additive versus subtractive?
I think one of the things is you can make probably more complex objects. But I think the other thing is this ability to take it and give it to people. You know, we tend to be tool makers. We like to build with tools, and so what you're seeing is a whole new suite of tools. The 3D printer is one of them, but it's not the only one. There's a huge revolution in people being able to do things with biology, with microelectronics, and all this is happening at the same time. It's happening in community settings. The other thing that's happening is people are giving a lot of these ideas away. Mm-hmm. So along with the old revolution came a lot of attempts to kind of control intellectual property. A lot of this is happening in open source communities. So people are creating designs, uploading them. It's almost like the Napster of things. And people can download digital designs and make them. So there's a sharing part of this that's very different that we saw it in the hacker communities back in the 60s and 70s when computers were taking off. Same thing is happening here. A lot of people are sort of sharing their ideas, getting into communal spaces, sharing information. That, I think, is a social revolution that's going along with the machines.
3D Napster.
Yeah.
Yeah. We first discussed having a discussion about this on the air after the President's State of the Union address, where he mentioned 3D printing. Was that a surprise to people in the technology community?
I know that I'd been talking to people about 3D printing, and the next day I got like 10 calls. Sort of like, what happened? It's State of the Union addresses are always focusing functions, but the follow-up is always, what happens afterwards? So I think there's always a sense of there'll be a bunch of people that always follow the State of the Union, and he said 20 things and we promised 10 things, and what actually happens. So it's interesting to think what will happen out of this mention of 3D printing. It was tied obviously to sort of changes in manufacturing, job creation. Is that going to happen? How is it going to happen? How soon is it going to happen? How are we actually going to implement what he said? And that's always the follow-up question to the State of the Union, because you can make lots of promises in the State of the Union address.
Are we at a point where we could talk about this, about 3D printing specifically, or digital fabrication generically? Are we at a point where we could think about it as having profound impacts on the economy?
Well, I think it's going to have initially profound impacts on the way we innovate. And part of every time we make something, there's something inside called the design, build, test cycle. We have to design something, we have to build it, we have to test it. And the first real use of this, which has been happening for a much longer time, is people start to use 3D printing to do rapid prototyping. So anytime I can compress that cycle, it doesn't matter what I'm making, whether I'm making a full dimensional object or a scale thing that I'm going to scale up, that has huge impacts on our ability to innovate. So there's I would say an invisible impact that three-dimensional printing has been having, simply because it allows us to rapidly prototype things.
So instead of days, weeks, or months to test your prototype, it could be a couple hours.
Could be. I used to be an industrial designer, and it was the biggest headache in my entire job, having to go from a sketch to actually building something. The other thing that happens is there's a bunch of people that really design with objects. Steve Jobs was one. Edwin Land, that ran Polaroid, was one. These are people that didn't go from their mind to a sketch that I want to build it. And so I would theorize, and no one's proven this, that actually could have an impact on innovation, because it allows us to go, we're three-dimensional creatures, it's very difficult for us to sketch things, actually begin to go from things in our head to objects. And once we have the object, we can test them out, whether it's actually testing it physically, thermodynamically, but we can also test it in focus groups. One of the early adapters of these printers are toy companies. Let's do some toys and give them to kids and see how they react.
Yeah, that sounds great to me.
So it's an innovation impact that's starting, that's even invisible now, I think.
You know, when we wanted to be able to share with our viewers a demonstration of 3D printing, we traveled out to this thing called the Fab Lab, which sounds like it was named as a part of an Austin Powers movie or something like that. We're going to take a look at a video now that we created, and that will give our viewers and listeners a little more sense of the scope of activity in this field. We'll hear from Phyllis Klein, co-founder and director of Fab Lab DC, also Sherry Lassiter from MIT's Center for Bits and Atoms, and a couple other people. And we'll take a look at that, and then Dave and I will come back and continue the discussion. Here we go.
A Fab Lab is a fabrication laboratory, or as most of us like to call it, a fabulous laboratory. It's a place where you can make almost anything that you can imagine. So you use computers to design, and computers to control industrial manufacturing machines, and you combine that with electronics and programming, and you can make functional systems. So you can make anything from, a model chair to an electric guitar, or to communication devices, or a solar house. So both in scale and in resolution and time, you can make almost anything you can imagine. So Fab Labs really came out of our research initiative at MIT through the Center for Bits and Atoms. So in 2001, we were tasked by the National Science Foundation to look at this boundary where the digital bits of the world meet the physical atom. So what happens when you build a smart building? What do the materials look like? How do you program that building, because it's going to have millions of interacting nodes? How do you debug that building? And all those sorts of questions. So marrying physical science and computer science together. And as part of that kind of a large grant, it was $15 million over 5 years, they require community outreach or educational outreach. And we decided that we make things in the interest of marrying physical science and computer science, and why don't we put a subset of what we do out into the field, into communities, to see if you gave people the ability to make almost anything, what would they do with that? And we were shocked and surprised, because people all over the world pulled for access to these tools and to the ability to modify and shape the world around them. And so that's how Fab Labs were born, in essence. And MIT continues to do the sort of foundational research that supports this idea of digital fabrication and personal fabrication.
It's really important that people can come to a place and experience this cross-pollination of ideas. People come seeking a community. They can find people who are experienced in areas that they're not. This information exchange, the support, and the possibilities for collaboration are really valuable.
I think the really interesting part of working in the Fab Lab is the idea that you are working next to all these different people, people coming from all different walks of life. For example, up in the Baltimore lab, we have inventors coming in to work on prototypes. We have designers, and I think it's interesting to sort of see that cross-pollination between the different disciplines. Artists drawing inspiration from engineers, and right now we have a biologist from Johns Hopkins working in our lab, and he's really interested in digital fabrication from a biological perspective. So I think that's one of the really unique things about Fab Labs is that, you know, all this cross-pollination and collaboration that is happening.
In the early 80s, I was at MIT in their pre-media lab thing and made interactive stuff. So when I heard about Fab Lab, I mean, actually what happened was I cut my hand and lost use of one of my fingers. So I'm sort of partially disabled. I can't build things the way I used to. So I thought, wow, I can use digital fabrication. I looked up to see whether there was anything in the DC area that I could, any place I could go to build things with a 3D printer, in fact, and I found Phyllis. So we've made circuit boards and we can turn lights on and off. And I'd already worked with an Arduino board. We've worked with a 3D printer. I mean, the ShopBot, and this is a little moonscape. I actually at one point worked at Goddard Space Flight Center as an animator. And this is sort of something that I was able to make. Instead of having a picture, you actually have the real thing.
I think what ties all these projects together, it's really an example of our creative community here in DC. We have so many talented people, people who come from areas of design, architecture, art, and everyday people who have found their way to Fab Lab because they're seeking a community to collaborate with, a forum where they can exchange ideas. And we also have a speaker series. So in addition to these people coming and developing their ideas and featuring their projects, they also have a very engaged group of people to get their ideas out there in the open and get valuable feedback as well.
Sense of the variety of applications, and one thing I'm wondering as we watch this is, how close are we to some sort of a tipping point where this type of manufacturing starts to become commonplace or well known, or even there's a consumer model like eventually we'll show off the 3D printer you have in your office. How close are we? What is the level of activity?
Yeah, I mean, I think certainly one area where there's some penetration already is in medicine. Mm-hmm. We've invested billions of dollars in figuring out how to slice and dice our bodies up and create digital models, so MRIs, CAT scans. So what I want is let's imagine somebody has traumatic injuries to the head. I can go in and create a digital model of their jaw and actually create a design for a replacement piece and print it. We can do that with dental implants. We can actually work on soft pieces like heart valves. So I think one area where there's a huge applications sort of ecosystem is going to be in medicine, simply because there's already enormous capacity to do digital imaging. The other thing is that when we look at these, we tend to think of these as hobby items. Mm-hmm. There's digital printers now for concrete that people are using to print very large objects. We're starting to see people talk about actually printing, the idea of printing a fuselage of a plane, car bodies. So I think this thing actually, we need to think about this scaling up both in terms of our ability to create modules and put them together, but also just print larger things.
What's the limitation of the basic materials that you can use? Is it something that needs to be able to be liquefied?
You should think of it as it should be material agnostic. So we tend to think of this as plastics. We can use epoxies in it. The aerospace folks are actually using electron beam welders to melt exotic alloys. Concretes, there's a whole bunch of chefs that are putting frostings through. So you really have to get away from this is something that I'm just going to use to print plastic objects.
The example we saw in the video of the injured hand and unable to now use tactile skills to create something, but you can do it on a computer and then build it through a 3D printer. It seems like it might remove a certain amount of craftsmanship from the equation. You don't have to be a skilled carpenter now. You just have to be able to have the right carpentry program.
Right. My uncle was a tool and die maker, and he was an analog guy. He lived in an analog world. He had a particular skill set, and people paid a lot of money for that. Now, what you see is a combination of sort of analog and in order to do this, you need some digital skills. So you may have to use some sort of computer-aided design program. There's a lot of people that are just downloading the designs and printing. So that is almost kind of, just click the mouse and something comes out. So it's a very, very different model.
Wow. So if I'm trying to get wrap my mind around sort of the consumer applications. So instead of ordering something from a catalog and then waiting for it to be shipped to your door, maybe you just order the blueprint, the digital blueprint.
Right. And you can download an awful lot of computer items. The other interesting thing to think about is if I'm the washing machine repairman and I used to have a huge inventory of spare parts, what happens if I could print those?
You don't have to pay for all that warehouse space and all of that inventory.
Right. Especially if it's something that's the demand is very low. So the idea of actually thinking about what happens across the supply chain when you start being able to do this. If I'm
Maytag man is salivating now listening to this.
Or the military, there's this whole concept of the teeth and tails in the military. So for every person I put on the front line to engage, there's lots of people. There's a huge logistics supply problem to support the people in the military. So there's a lot of thought going on. What happens if I can actually produce on the front line or produce where I need to produce things, either using these kinds of things or biologically?
We have another piece we want to share with our viewers and listeners, and this is an example of 3D printing, also shot at the Fab Lab, and our host is a gentleman by the name of Alex Baddick, and so we'll take a look at that and then come back and talk about Dave's 3D printer as well.
What 3D printing is basically taking a digital file from a computer and creating that as a real physical model using a printer. And basically the way it works is you're taking a filament of material and you're melting it, and when it liquefies, it lays that material down and it hardens. It drops the tray, it then lays another layer of material down, that hardens, and it builds that part up so that it goes from a digital file to an actual plastic part. Traditionally, when this technology sort of came out, it was mostly for mechanical engineering applications. That's where they envisioned it being used. But now that people have discovered what it can do, it's gone from a range of, there's art programs that use this, medical applications, dentistry, military, a lot of different applications like that. Pretty much anything where you want to make something, a 3D printer can be used. All right, so I'm going to take you through actually printing a part on a 3D printer. This is an example of the washing monument that I modeled in a 3D CAD software package. And here's the actual 3D model on the computer. So in order to print this, I'm actually just going to open the part. And then I'm just going to save this as a file type that the printer understands, which is an STL file. And basically what that does is it changes the file into a bunch of different triangles that are easily sliced up by the print driver. So now, once I'm in the print driver, I'll go find my monument piece and click Open. And now I can orient the part the way I want to get it to print properly, so I'll stand it up. And then all I need to do is click the Print button. And now the computer takes over, and it will slice the part up into individual layers so it can lay this part down while it's printing and know exactly where to place the material. So now that the part's been sent to the machine, everything else from here is automatic. The machine's taking a filament of material that looks very much like a weed whacker string, and there's a motor that pushes that filament through a liquefier tip, and that melts the material. And then the machine is being controlled basically by the computer, and it's moving the head based on the tool paths that the computer sliced up for the head to follow. A lot of people think of this thing as sort of a glorified glue gun because all it's doing is taking a filament of material, melting it, and laying it down as a liquid, and it hardens immediately. Then the table drops down, it lays the next layer, and it builds the part up off of the tray. So a very accurate glorified glue gun is a very good description of how the technology actually works. So personally for me, one of the nice things about having these in my office is when I have a couple hours here and there, I can come up with my own projects to do. And my most recent project that I completed was a completely 3D printed guitar body, and used this technology to print out each of these sections on my 3D printer and assembled it, sanded it down and painted it, and it actually plugs in place. So basically, the future for this technology, I think, comes from more materials, higher resolution, quicker builds. I sort of imagine maybe a day where, and this would be well into the future where you don't necessarily need to go to the store anymore. You may download a product and print it out at home and have your product. So that's kind of the sort of science fiction idea of where this would go. But everything starts as science fiction. 100 years ago, no one could fly. Someone had the idea that you could, and they figured it out. So this type of technology, you can just sort of see it. We're at the bottom of where it's going, and it's changing the way the manufacturing happens.
If the guitar were here, you could play it among your many skills. You're a guitarist. That's pretty impressive. Show us yours. Talk to us about what we have here on the set. He talked about the glue gun metaphor.
Right.
Do you like that? Is that an effective way to describe it?
This one uses a syringe. So this is a little bit different. I can put epoxy in here. Again, I could also put Nutella in there if I wanted to do some interesting sort of cookies. This one is something I built as a kit. And it actually, there's another machine that's out there.
How much does something like this cost?
This was about $1,800. It took me probably 18, 20 hours to build it. There's another machine that actually made the parts. This is essentially a computer control laser cutter. So this is what was left over, and it's just basically put together with an Allen wrench and screws. So there's what you're seeing is an ecosystem of digital fabrication machines. This is one of them. And these sort of move across. This is something that the biologists have done. This is most biolabs need a centrifuge. You remember you heavy spin it, you got to spin. So they're expensive. This came out of a 3D printer, this gray piece, and this is it's called a Dremel fuge. I think we paid $20 to buy it, but I could have printed it if I had the code. And this is just you put it in a Dremel tool and you spin your samples.
And the durability on something like this. So if we built a hammer, could we use it to drive a nail?
It doesn't have a lot of mass, but you probably could do it in quickly. And again, because we can begin to print metals and concretes, this opens up capacities to do actually things that will stay around for a while. So again, this is just one of a whole suite of tools.
And if we were to turn the switch, we would see that syringe moving in all kinds of ways, dropping down this epoxy and building something from the ground level up.
Same principle as you saw in the
So
film.
this would be the consumer model.
This is the consumer model.
When we reach a certain price point. Maybe this isn't in every household at $1,800, but it gets down to $200 or something like that.
Yeah, and the other question is where this actually ends up. I mean, if we think back to the computer revolution, what drove that was not the hardware. It was the fact that at a certain point it went beyond hobbyists and we all became addicted to the software. So what really took off was when we could get spreadsheets, word processing programs, desktop publishing. Then I bought the hardware, the printers and the computer, because I wanted what the software could do. So the question I always have is sort of what is that kind of killer app out there on the software side?
Well, that is, where he uses the example in the video of airplanes. We couldn't fly 100 years ago, but not everybody owns an airplane. But mostly everybody now does own a printer.
Right.
So where do you see this headed in that regard? Do you imagine that there is some application where these become standard operating tools in any household?
I can see a lot more application on the industrial side, actually. It's not clear. I can imagine this particular sort of fragmenting, that some of these will end up in the kitchen. Some of them will be some shop tools. I'll basically put in additive manufacturing along with my, my router, my drill press and saw. Some of them may end up in the office. So I don't think we know kind of how this will happen. I can imagine it going into multiple submarkets.
Well, I hate to go sensationalist on you because I know that when a lot of this type of new technology makes its way into the mainstream press, it's often in an alarmist type of reporting. We saw recent stories about could 3D printers be used to create guns and gun parts. I imagine if Mary Shelley were writing Frankenstein today, it wouldn't be dead body parts, it would be creating a human through a 3D printer. Give us, what are some of the downsides or the areas of concern, applications that are potentially troubling?
I think that the gun parts has obviously been kind of overblown. I mean, it got everyone's attention. People can do a lot of damage with regular guns. I don't need to make plastic ones. I think one of the things that's we have to be thinking about is we're very material intensive. So if I'm in an industrial society, you and I, we're basically every year mobilizing 100 to 180,000 pounds of stuff just through our consumption patterns, the way we travel, the energy we use. That's about 300 grocery bags of materials a week per person. That's a lot of stuff. So I think anytime we put technology in society where we're actually sort of doing something with the material ecosystem, we need to think this through. And I don't think we've done enough of that. So where these end up, what I print, how many of them I print. We remember the paperless office, which we never quite realized. Do we want people printing lots of things? What materials are we going to use? Are we going to make these recyclable, remanufacturable? Can we make them break down or reuse them? So I think there's a whole bunch of environmental questions that need to be answered, and they need to be answered now rather than waiting till these sort of get into society and we start using a lot of them.
Is this the area the Science and Technology and Innovation Program will be focusing on,
these
public policy discussions?
Yeah, we're going to be doing some of that work this summer, actually, because I think we need to look at this as from a life cycle standpoint, sort of cradle to grave, what happens at the end of the life? Can we sort of recycle these, put them back in? I think the other interesting thing about this is job creation. How is that going to happen?
Right.
I'm just going to throw a bunch of these out there.
Some blind faith it will, but we don't know yet.
So I mean, one option, if you look back at agriculture, another production system, in the 80s people set up community-supported agriculture. It's grown, it's explosive, it's basically brought back small farms, so you and I can actually sort of spread the risk of the farmer. We actually buy part of the crop, and in the end of the harvest season, we get some of that. Is there a community-supported manufacturing model where you and I, as part of the community, actually support local production with local skills, local materials, local consumption? I don't think we've actually thought through the business model. We had that in agriculture, it's taken off. Is there a way to support people using these kinds of devices in communities?
Well, I'll make a promise. We'll invite you back and maybe add some other guests, and we'll explore that question in more detail next time, because we're out of time this time. But thank you very much for this introduction to 3D printing. That's all for this edition of Dialogue at the Wilson Center. Until next week, I'm John Molesky. Thanks for joining us.
We'd like to hear from you. Please send your questions or comments to dialogue@wilsoncenter.org. You can also follow us on Facebook. Search Dialogue Television and Radio. Our host's Twitter feed is twitter.com/John Molesky. Dialogue is a co-production of the Woodrow Wilson International Center for Scholars and MHZ Networks. Dialogue is available via broadcast, cable, satellite, and telco on MHZ Worldview throughout the United States. To see how to watch where you live, visit www.mhznetworks.org.